Hey everybody, welcome back to another fun and exciting geometry class. Today we will be on page 137. This is lesson 3.5. 137 talks about diameters, and we're going to be there on lesson 3.5. When we talk about diameters, we first of all kind of really have to define what a diameter is. I think most of you know what a diameter is. It is the distance from one point on the circle through the center point ending on another point. Okay, so starting on the circle, through the center point, ending on another point. That's the diameter. Well, look at theorem number 35. A diameter or radius, so this one could actually be either one right here, diameter or radius, that is perpendicular to any chord is a bisector of that chord and the arcs subtended. A diameter or radius, so either one, that is perpendicular to any chord is a bisector of that chord. So let's take a look at that. So we have a chord. Our chord is AB. And what does it say about the diameter or the radius? It is perpendicular to the chord. What does perpendicular mean? Perpendicular means, now I'm not going to take the time to do it right now, but perpendicular means that you basically construct a perpendicular bisector. Okay, how do you do that? Well, you take the endpoints. Okay, and this goes back to the beginning of the book when we learned how to do this construction. You make a mark here, you make a mark here, and then you take your compass and you open it up and it puts an X here and then it puts an X down here. Okay, and then you connect those two. So that's the construction. I'm not going to take the time to do that. It's very hard for me to do it on this program. So I'm just going to kind of review over that real quick with you. But you need to remember how to do the construction of the perpendicular bisector. So if we draw a perpendicular bisector of this, or going back here, a radius that is perpendicular to the chord. So if we put one in here, okay, notice that it perfectly bisects AB. It cuts AB in half. When we draw a diameter that is a perpendicular to AB, what does perpendicular mean? It means that that's a 90-degree angle right there. Okay. What ends up happening is that it creates a bisector. So we could call this point C, we could call this point D. Notice some other things that it does. When it does that, it takes this arc right here. It takes arc AB and it cuts it in half. So BD is one half and AD is the other half. So not only does it bisect the chord, it also bisects the arc that it's subtending. We can also notice some other things here. Some other things that we've already talked about in other chapters, other lessons. Notice that this would create a triangle right here, and we know what kind of triangle that creates. Okay, that's going to create an isosceles triangle, and no matter where that chord is, it's going to still create an isosceles triangle. It's just maybe AB, we'll call this point O right here in the center. AO might be a little bit longer, might be a little bit shorter, but AO is always going to equal BO. They're always going to be the same. AO and BO are going to be equal because we've created an isosceles triangle there. How do we know that we created an isosceles triangle there? Because when we bisected that with a perpendicular, we know that every one of these points, remember this is something that we learned in the location, every one of these points is an equidistant from the outer points, from AB. So no matter where we are on this, we're always going to have an equilateral triangle. So it just happens to be that we're going from the center point O, but it creates an equilateral or an isosceles triangle, sorry. But these AO is going to equal BO every time. Another thing that it's going to create is AC equals BC. And so that's an interesting thing that it's doing right there, is that AC is going to equal BC. It's going to bisect that. So it's going to create a lot of equal parts. Now, if you've been paying attention in geometry, whenever we work with proofs, we do a lot of, hey, something bisects, then this is equal to this. And so we need to prove that this is equal to this. Then if we bisect it, then that proves that those two pieces are equal. We can prove a lot of things. This is a very, very useful. I'd put a star next to this theorem because you're going to come back to theorem 35 quite a bit. So there's several other things, corollaries that would go underneath of this theorem, but that's a very important theorem. Make sure that you pay attention, make sure that you learn that one. The first corollary, 35.1, it's there on page number 137 as well. Diameters that bisect a chord, not another diameter. So we're not talking about like, okay, so we have a circle, diameter, diameter. Well, we're not talking about that. We're talking about a diameter that bisects a chord, any other chord, not a diameter. Okay, so we're not talking about multiple diameters, because diameters are chords. You understand that, right? Diameters are just special types of chords. So this corollary says diameters that bisect a chord, not another diameter, is perpendicular, or I guess that should say are perpendicular. The way I wrote that would be are perpendicular to the chord. What does that mean? That means that if I have a circle here, and I'll just draw a quick circle, small, and if I have a diameter that bisects a chord, so if I have a chord, put a chord here, and if I have a bisector, a diameter that bisects that, okay, what does it tell me about that? That means that it is perpendicular. So again, if we're doing proofs, this is something that's very important. As soon as we determine that that is a bisector, that's a chord, that's a diameter, that's bisected. As soon as we tell that, the other thing that we can tell that it's perpendicular, what does that mean? It means that I now have a right angle right there on both sides. Okay, that whole thing, all that's a right angle. So what is that going to tell me? Well, let's say I connect these 2 points. Well, look what I just did. I created a triangle, a special triangle, a right triangle. Connect those 2 points. Oh, I have all kinds of stuff that I just did right there. I now have an isosceles. I now have 2 right triangles. I now have 2 equal. I have 2 congruent triangles. All kinds of things just happened right there. And you could do the same thing over here with this side and create all kinds of different triangles. You're going to see these in your proofs coming up through the next few lessons here. All right, corollary 35.2, the perpendicular bisector of any chord passes through the center of the circle. So we'll just draw a random chord. All right. So if I bisect that and it's a perpendicular bisector, now I'm actually going to get rid of that center point because I didn't see if that was the real center point, and I just randomly put that there. So if we take and we bisect this, okay, with a perpendicular, so remember, again, we'd have to construct this. I'm not constructing it right here. But if I were to construct it, and if we got it perfect and it was an exact right angle, it's exact perpendicular, then it will pass through the center point. In other words, if the center point has to be on that line. Okay, it can't miss the center point. In other words, any perpendicular bisector of a chord must be a diameter. It can't be anything other than a diameter. Okay? It can't be another chord. Look what happens if it's another chord. So let's say it's another chord. Well, then it's not bisected. Okay? So if it's a perpendicular anywhere else and it doesn't pass through the center, then it's not a diameter. So the only one that this works for is the diameter of the circle, and it will pass through the center point. It must. That's corollary 35.2. The last one for today's lesson is corollary 35.3, and it says a perpendicular drawn from the center point to any chord bisects the chord and the subtended arc. So let's do what it says. A perpendicular drawn from the center point. All right, so let's go from the center point right here to the chord. Notice if we do that, and if it's perpendicular, notice what happens. So we drew the perpendicular, just like it said, that we drew the perpendicular from the center point to any chord. Notice it says it bisects the chord. So we can know for sure that chord AB, and we'll call this point C, is bisected. So we know that AC equals BC. We know that. Why? Because this corollary tells us, because this theorem tells us that. Another thing that it tells us is that we'll call this D, AD arc is going to be equal to the BD arc. Okay? Because it also says that it subtends the arc. It bisects the chord and it bisects the subtended arc as well. All right, lots of stuff there with the diameter. Wasn't a super long lesson. Hopefully you understood that. That's one, if not the most important lesson in the circle chapter. That is probably in the top 2 or 3. You have to understand this lesson. If you don't understand this lesson, you are not going to understand how to do the proofs going forward. So make sure that you got all that it kind of clicked to you, and you kind of memorize those, put those into your memory bank so that when you get to the proofs later in the chapter, you'll be able to go back to that and you'll be able to say, oh yeah, because of corollary 35.1 or because of theorem 35, oh yeah, that is bisecting that, and so that is equal to that. That's creating an isosceles triangle. All these other things that you can, all these things that you can put together from this theorem 35. All right, we'll see you later. Have a good one. Bye-bye.